In our section 6 notes, we're going to take a look at simplifying radicals that aren't perfect squares. So in section 5, remember, we introduced the topic of radicals. So in general, a radical is when you're taking the root of some number. So n is what we call the index. It indicates what root you're taking. And then the number underneath the radical is what we call the radicand or radicand. Okay. So there are a couple important things to know about radicals. So the first thing is the product property of radicals. So if you have two numbers, a and b, where at least one of them is greater than 0, then the nth root of a times the nth root of b is the nth root of a times b. So it is important here that n is the same. So I can only multiply two radicals that have the same index. So if they don't have the same index, I can't combine them. So it is important here that n is the same. And then simplifying radical is when we write a radical with no perfect root factors. So for example, we know the square root of 25 is 5. Okay, but that's not what's called simplifying a radical. That's taking a square root or taking a root. What we don't know is the square root of 50. If I were to plug the square root of 50 in my calculator, it would give me out a decimal. So what we're going to be focusing on here in section 6 is simplifying irrational numbers. So if you remember from section 5, irrational numbers are numbers that aren't perfect roots. So that could be a cube root, a fourth root, a square root, a fifth root, any root where it doesn't simplify to a whole number. Okay. It is, again, we're going to be assuming that all of our variables and numbers, we are looking at positive roots, not just, because remember we discussed that a positive and a negative number squared both gave us the same number, but we're going to assume here that we're dealing with all positives. So when we are simplifying radicals that aren't perfect squares, we break down and we kind of create a tree of the multiplication that can lead us to that number. So simplifying the square root of 18. You're allowed to break it down however you want, as long as the number is multiplied to 18. So there's like two different ways here I could break this down. 6 times 3 or 2 times 9. It does not matter. Now, it is better if you simplify it using a perfect square. So 2 times 9, 9 is a perfect square. And 9 breaks down as 3 and 3. So when we are simplifying a radical, we're looking for a perfect square that goes into it. And if there's a perfect square that goes into it, I can bring that number outside. Because remember, I can break up 18 as the square root of 2 times the square root of 9. And then I can simplify each of those square roots independently. So we know the square root of 9 is 3. Now the square root of 2 can't simplify, so it's going to stay square root 2. And that's going to be my final answer. Okay. 288, we are going to treat the same way. Now the goal is to always think of a perfect square that goes into a number first, but it's not always as obvious. So when it's not as obvious, I would, and you're dealing with an even number like we are here, I would also divide by 2 first. So 288 divided by 2 is 144. Now we do know 144 is a perfect square. It's 12 times 12. So I could rewrite this as the square root of 2 times the square root of 44. So I can simplify that 12, bring it outside, and I, again, would leave the 2 underneath the square root. Next we have 5 square root 54, which I'm going to, just to show you how to do it if you can't think of the perfect square right away. So 54 divided by 2 is 27. So 2 and 27. 27 is not a perfect square, but I can break it down as 3 times 9. 9 is a perfect square, which breaks down to 3 and 3. So I have this 3. So I can write this as 5 times, now unlike our last two examples where we just had one other number, I have the square root of 2, the square root of 3, and then I have the square root of 9. So the 5 that is out in front here has to multiply with the 3 that we're going to simplify from the square root of 9. And the square root, the 2 and the 3 are going to multiply back together underneath the square root, because we're not going to write 2 square roots as part of our final answer. So 5 times 3 is going to give us 15, and then underneath the square root, we're going to have a 6. Our next example, we're going to be dealing with the cube root of 54x to the 4th. So I'm going to break down 54 the exact same way I broke it down previously. 2 and 27. 27 is 3 and 9. 9 is 3 and 3. The difference here is that I have a cube root, which means in order for it to simplify, I'm looking for a perfect cube, which means 3 of the same number. I also have my x to the 4th, which is x times x times x times x. And if we remember, when we're dealing with variables with exponents, we look for groups of the size of our root. So a group of 3 here. So I have a 3 that is going to simplify. I have an x that's going to simplify. But then underneath my cube root, I'm still going to have a 2 and an x that didn't simplify. Next we have 25, the square root of 25, a to the 4th, b to the 9th. So 25 is a perfect square. It's 5 times 5. So I'm going to be able to simplify that. Then we have a to the 4th, and then we're going to have b to the 9th. So when I'm looking at my a's, I have 2 groups of 2 a's, and then my b's, I have 1, 2, 3, 4 groups of 2 b's. So when I'm simplifying it, I have my 5. I have 2 groups of a, so a squared. I have 4 groups of b's, so b to the 4th. But the b's had a leftover b that didn't simplify. So even though there's no number left over underneath my square root, I still have 1 b that's left over. Next we have the square root of x to the 7th, y to the 8th, z to the 9th. Now I'm not going to write out all of the x, y's, and z's here. I'm going to do this intellectually. So if we think, how many groups of 2 are there in 7? And there are 3. So I'm going to have x cubed. How many groups of 2 are there in 8? And there's 4. So we're going to have y to the 4th. How many groups of 2 are there in 9? 4 there, so we're going to have z to the 4th. Underneath the square root, 7 and 9 don't go into 2 evenly. I have one x left over, and I'm going to have one z left over. Because 8 does go into 2 evenly. So I don't have any y's left over. Last example, 4th root of 32, a to the 9th, b to the 20th. So 32 I'm going to break down as 2 times 16. 16 I'm going to break down as 2 times 8. 8 is going to break down as 4 times 2. 4 is going to break down as 2 times 2. So in this case, I have a 4th root, which means I need to have 4 of the same number in order for it to simplify. So I have 4 2's there, and then I have one left over. So I'm simplifying this. I'm going to have a 2. Then I'm going to move to my variables. So a to the 9th. How many groups of 4 are there in 9? And there are 2. So a squared. Then I'm going to move to my b. B to the 20th. How many groups of 4 are there in 20? And there's 5. So I have b to the 5th. Underneath my root, I have my 2 that didn't simplify. And then when I took out my 2 groups of 4 from 9, I had 1 left over, so I have an a. But 20 splits evenly into groups of 4, so there's no more b's left over. So that is my fully simplified form. So what I want you to do now is go ahead and pause the video and see if you can do these next 3 examples on your own. So simplify the square root of 81y to the 5th, the cube root of 24 a to the 9th, b to the 4th, and the 4th root of 32 z to the 7th. And then when you're done, press play again to see the solutions. So 81y to the 5th, square root. 81 is 9 times 9. We'll have 9. There are 2 groups of 2 in 5, and then I'm going to have a 5 left over. So we get 9y squared, square root y. Cube root 24 a to the 9th, b to the 4th. 24 is 2 and 12, which is 2 and 6, which is 3 and 2. So I have, just going to rewrite the 2 and the 3 so my 2's line up. So I have a group of 2's, so 2. There are 3 groups of 3 in 9, and there is 1 group of 3 in b to the 4th. Then underneath the cube root, I had a 3 and a b left over. Last one, 4th root of 32 z to the 7th. So 32 is 2 and 16, which is 2 and 8, 2 and 4, 2 and 2. So I have 4 2's, so I'll have a 2. There is 1 group of 4 in 7, so then just a z. Underneath the 4th root, I have a 2, and I'm going to have 3 z's left over. One of the things I would make sure you're doing when you're simplifying these with variables and you have a higher root, like a 3rd root or a 4th root, is make sure it's clearly an index and not the exponent of a variable. So you notice how I leave just a tiny bit of a space between my last variable and my index for my root, just so it's obvious that it's not the exponent with that variable. So the next thing that we're going to look at is multiplying 2 radicals and then simplifying them afterwards. Okay. So just like with the first page, we're going to assume all of our variables are positive numbers, same thing as our numbers. So we have the square root of 3 times the square root of 5. So I can go ahead and multiply that. and I'll get the square root of 15. Now, if I try to break down 15, it just breaks down as 3 times 5, which are not perfect squares. So that's it. Square root 15. Square root 6 times square root 21. So we're going to do 6 times 21, and we're going to get the square root of 126. Now, when you're trying to break these down, afterwards to see if they simplify, break them down as the numbers you multiplied by. So 6 and 21. 6 is 2 and 3. 21 is 3 and 7. So I do have a 3 that I'm going to be able to bring outside. And then underneath the square root, I'm going to multiply my 2 and 7 back together to get me 14. Next, we have the square root of 8x cubed times the square root of 6x. So 8 times 6 is going to give me 48. X cubed times x is x to the 4th. Okay. Break down 48, 8 and 6, 4 and 2, 2 and 3, 2 and 2. So in this case, I have 2 groups of 2. So we haven't done an example here where I have multiple groups of a number. So if I have multiple groups of either the same number or different numbers, I just multiply them together. So I'm going to do 2 times 2 outside my square root. And then I have my 3. Oops, I forgot about the variable. Okay. I forgot to simplify x to the 4th. Now, x to the 4th. There are 2 groups of 2 in x to the 4th. So we'll have 2 times 2 and then x squared. And underneath the square root, we'll still have our 3. And 2 times 2 is going to give us 4. So we'll have 4 x squared square root 3. This next example is written wrong, so the first thing we're going to do is rewrite it. It should be 2 square root 12xy cubed times 3 square root 30 x squared y. It's my bad. Shouldn't all be underneath the square root. So if we are multiplying and there are numbers in front, those numbers are going to multiply together. So we'll have 2 times 3, which is 6. Underneath the square root, 12 times 30, which is 360. X times x squared, which is x cubed. Y cubed times y, which is y to the 4th. And write down 360, which I'm going to do is 12 and 30. 12 is 2 and 6. 6 is 2 and 3. 30 is 2 and 15. And 15 is 3 and 5. So I have a pair of 2's and I have a pair of 3's. So on the outside of my square root, I'm going to have 6 times 2 times 3. Oops, again, I forgot the variables. And then there's 1 group of 2 in x cubed, 2 groups of 2 in y to the 4th, so xy squared. Underneath the square root, I have a 2 and a 5. They're going to multiply back together to give us 10. And I have an x left over. So 6 times 2 times 3 gives me 36 xy squared square root 10x. We have not done an example where we have a higher root. So we're going to do an example with a cube root. So we have cube root 16 m squared n to the 4th times cube root 40 mn. Both of them are cube roots, so we are allowed to multiply. So 16 times 40, which is 640. And then we'll have m cubed n to the 5th. Now I break down 640. I'm going to have 16 and 40. I'm going to have 2 and 8, 2 and 4, 2 and 2. Break down 40 as 2 and 20, 2 and 10, and then 2 and 5. So in this case, I'm looking for 3 of the same number. So I have 3 2s, and then I have another 3 2s. And I have a leftover 2 and 5. So my 2 2s are going to multiply together. Then my variables. I have m cubed, so that's one group of 3. So I'm going to have an m. I have n to the 5th. There's also one group of 3 there, so I'll have n. Then I'll have my cube root. My 2 and my 5 are going to multiply to give me 10. And I have 2 leftover n's. So I'm going to have 4mn cube root 10n squared. Last thing we're going to talk about is adding and subtracting radicals. So you can add and subtract radicals that are like terms. So like radicals. So can add / subtract that are like radicals. So what that means, what are like radicals? So like radicals are radicals with the same index and radicand. So that means is you have to be taking the same root, and what's underneath that root has to be the same thing. So our first example, we have 5 square root 15 plus 2 square root 15. So we have to ask ourselves, are these like radicals? And this answer is yes. They're both square roots, and they both have 15. So when we're adding like radicals, we add the numbers that are in front of the radicals. Just like if I were adding 2 variables. If I had 5x plus 2x, I would add 5 and 2 and I get 7x. It works the same thing with radicals. So we'll get 7 square root 15. So next we have 9 cube root 2y minus 15 cube root 2y. So again, do we have like radicals? So we have, both of them are cube roots, and underneath those cube roots we have 2y. So they are like radicals, so I'm going to subtract my numbers. So I'm going to do 9 minus 15, which is going to give me -6, and then cube root 2y. Next we have the square root of 20x minus 6 square root 16x plus square root 45x. Do we have any like radicals? They're all square roots, but they all have something different underneath the radical. That doesn't mean that I can't combine anything. What I need to check in this case is to see if any of the radicals are going to simplify. And if they simplify, maybe after they are simplified, I'll have like radicals. So 20 can break down as 5 times 4, and I know 4 is a perfect square. It's going to give me 2. 16 is a perfect square. It's 4 times 4. And then 45, I can do 5 times 9. 9 is a perfect square, 3 times 3. So when I go to write my simplified radicals, I'll have 2. Now if I look at my x, I only have 1 x underneath my root, and I'm taking a square root, which means I'd have to have 2 of them in order to simplify it. And I can't here. So it's going to be 2 square root, and then I have my 5, so 5x minus, now 16 is 4 times 4. So that 4 is going to come out and multiply with our 6, and we're going to have 24 square root x plus the 3 is going to come out and underneath the square root we'll have 5x. So now that I've simplified it, I have two like radicals. I have two radicals that have square root 5x, which means I can do 2 plus 3. So that's giving me 5 square root 5x minus 24 square root x. So the negative 24 square root x didn't have a like term, so it's not going to combine with anything, but the other two can. Next, we have the square root of 50 minus the square root of 18. Both square roots, but different numbers underneath those roots. So we're going to simplify them. 50 is 2 times 25. 25 is 5 times 5. 18 is 2 times 9. 9 is 3 times 3. So it's going to simplify as 5 square root 2 minus 3 square root 2. Now that they're simplified, they're both square root 2, so I'm going to do 5 minus 3, and I'm going to get 2 square root 2. Last two examples we're going to look at have to do with the cube roots, just again to get some examples other than square roots. So cube root 24 minus 4 fourth root 192 plus cube root 3. So I know that even if I can simplify the fourth root of 192, it is a different index than the cube root of 24 and the cube root of 3. So it's never going to be a like radical with the first and third terms. But I'm going to still see if it can simplify, just because I want to make sure my final answer is as simplified as possible. So 24, I'm going to break down as 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So I have a group of 2's. 192 is 2 and 96, which is 2 and 48, which is 2 and 24, which is 2 and 12, which is 2 and 6, which is 2 and 3. So I have 1, 2, 3, one group of 4 2's. And then cube root 3 can simplify. That's the smallest it gets. So I'll have 2 cube root 3 minus that 1, 2 I can bring outside is going to multiply by my 4 to give me 8. So minus 8 fourth root. Now I have a 2, and a 3 left over, which are going to multiply to give me 12 plus the cube root of 3. So now I have like terms. I have my 2 cube root 3, and I have this invisible 1. So I don't write the 1 in front, but it is there. So I have 2 plus 1. So this is giving me 3 cube root 3 minus 8 fourth root 12. This is an example that's a little bit on the more difficult side of a problem I expect you to know how to do, but it is something you might see, but it is a little bit more difficult. Okay. Then the last example, x cube root 16 x to the 5th plus 2 cube root 54 x to the 8th. I'm going to break down 16, 2 times 8, 2 times 4, 2 times 2, 54, 2 times 27, 3 times 9, 3 times 3. So I have one group of 2, and I have one group of 3. So that group of 2 is going to come outside with my x. Now I do have an x to the 5th underneath the cube root, which does have a group of 3 x's in it that I can bring outside. And then underneath my cube root, I'll still have a 2 and 2 x's that couldn't simplify, x squared. For my next term, the 3 is going to come out and multiply to the 2, so it's going to give us 6. X to the 8th has 2 groups of 3 in it, so x squared. And then underneath the cube root, I have a 2. And I also have 2 x's left. So if I look, I now have a cube root 2x squared and a cube root 2x squared. So I now have like radicals, which means, and then the 2x times x is going to become 2x squared. And then I have a 2x squared plus a 6x squared, which is going to give me 8x squared cube root 2x squared. Please let me know if you have any questions about simplifying radicals or adding or subtracting radicals.